Hello, this is DevLog number 2 for GF2. Let me show you real quick what was the state of the game for the previous DevLog. Basically, we had the prototype up and running with fonts and glow effects and some background stars. So the idea for the background stars was to get like a benchmark for how the graphics pipeline was, working out. We were able to get up to like 300K objects being rendered and not dropping below 60 FPS, which is a good enough, benchmark in my mind. Mainly because, I mean, just look at this thing. I mean, I'm probably not going to be doing something like this because it's just so like crowded that you cannot even look at, you know, something else on the screen. But again, this is just for, performance testing. Now, these objects, as of for this version, they were not part of the physics engine, meaning that they were not interactable in any sense. And I wanted to change that to also have like an understanding for how the physics engine was going to work out. So for the current version, I've actually added that plus a couple more things. Like now we have buttons. So if you're on your phone, you can actually, either with the mouse or with the touch pens, you can click them, and each of them is assigned a different thing to do. Like this controls the glow strength, so if you want to look at uh, a thing's brighter or something. And I also added like a simple toggle thing for slow motion, effect. This is useful for a variety of reasons. But going for the main thing that I worked on was, adding, collision checking for the, I'm gonna call them stars, although they are boxes as of right now. I had to switch up the sprite because the other one was kind of very ugly for this test that I was doing. So it's very simple. You essentially, drag around the stars, and they inherit the velocity of the thing that hit them, and also change velocity so that they go the opposite way. It's a very simple, callback system that I'm doing for this physics collision resolution. We're doing 10K, but I was able to get, the single threaded version, which is this one, go up to 50K without dropping to from 200 FPS. But if we keep spawning entities, we eventually start to see some performance degradation. I think for 80K, we'll go to 100 FPS and a little bit below that. And if we spawn, I don't know, another 10K from here, then we're actually going to see that the performance will start degrading like very noticeably. And if I spawn another 10K, then we cannot return from this because we reach like the territory of like 5 or 10 FPS. It's very bad. So that was the benchmark for like single threaded. This is as far as I could look at the algorithm to make the resolutions. And let me show you what was the uh, best result that I was able to get by introducing multi-threaded to the physics system. So I'm going to spawn the 80K as I was mentioning. So before, I think the baseline was like 100 FPS or something. With all threads available on the CPU doing work for this game, I was able to get it to 150, something like that, which is a very good number based on how the single-threaded application was behaving. I can keep spawning, I think, up until like 120K. The FPS is not stable at 60 FPS, but it is still somewhat playable in this state. So yeah, that was about it, for the updates. It took me quite a while, but I wanted to do it the right way because sometimes when you do optimizations, especially with multi-threading, you can actually degrade performance. And for that, I've actually written a couple of statistics. So these are not manual. I've added some simple test configuration variables to the engine. Basically, if we enable both of these, one enables a timer that every second stores the FPS counter onto a CSV, and the other one grows the entity array um, each like every 2 minutes. So, for instance, let me show you real quick the single threaded one. So at from 0 to 120 seconds, we work with like 70 entities, and here we spawn like 80K entities. Now you can see right away, how the gap actually increases and how it actually degrades the more it stays there. It can be to uh, you know many different factors. Maybe memory growth is actually hurting, when we try to index other parts of the memory that we're storing. Like that is something that I will have to, analyze further down the line. But here, the idea was to only understand how much, worse or better was to introduce more threads to this implementation. And even using 4 threads actually improved quite a bit. Um, this gap is not as big as with the single threaded version. So even like I did from 0 to 24, which was the max number of threads that I had available for the CPU. And here it was very obvious that I was getting much better numbers. The I mean using the highest amount of threads that I called. Now I figured at the time that uh, even if I didn't get like this much performance boost on all platforms, it should somewhat still be better. But this was not the case for either Android or web. So I had to, currently disable multi-threading for both platforms. So the idea is that for both Android and Scrivener or web, whatever you want to call it, the scheduler is actually something that you have to fight. So for Android, the moment that I start, spawning threads and adding work to them, synchronization becomes one of the biggest pain points to deal with. And I could not get around it. No matter the configuration that I tried, I tried different mechanisms by which we were sending work to the threads. The simple fact that I had to synchronize was an issue. So this meant that for the current engine to actually utilize more threads on either platform, I will have to split up completely the physics representation and the rendering representation, which, I mean, it doesn't sound bad, but it would require like a very big refactor. And what I would like to understand first, if I can reach the goals that I want with the single threaded, efficiency, then I will just leave those platforms alone, single threaded. And then for desktop, then we can just go crazy with the effects and everything. So I think this is it for me. I mean, as with the previous devlog, I'll leave the link if you want to test out the web version. And thanks for watching.